Hello, my name is Jeff Morris. I am a senior software engineer at Couchbase, and today I'm going to present performance optimizations using OpenTelemetry. So very quick, we're going to go over the agenda. We're going to warm up with the backstory. We're going to talk about tracing 101, and then the tool set that's available for you in the SDK. And then we're going to go over tracing metrics in the ecosystem, briefly go over performance implications, and then finally conclude with a monitoring example using tracing. So first, the backstory. So you're on vacation, enjoying yourself, relaxing, and maybe drinking a Mai Tai, enjoying the view, when all of a sudden, ring, incoming call. Who can it be? It's the travel app is slow. It's a user, and the user is upset because the travel app is slow, and it's impacting their ability to do their job. So what's the moral of the story? Well, reactively waiting for users to come to us and tell us that we have problems in our system is a recipe for failure. Instead, we should proactively be monitoring our system and finding hotspots and errors or issues and resolving them. So, tracing 101. So, tracing 101, there's 3 pillars to monitoring your system or your application. The first is event logs, event logs give you immutable timestamp records or discrete events over time. Think exceptions, think maybe the beginning, maybe you're going to log the beginning of bootstrapping is going to commence, and then you're finally going to finish bootstrapping, and you'll log that event. Things like that, of that matter. Secondly, we have metrics. So metrics are numeric representations of data measured over intervals of time. So usually we use histograms to measure percentiles, but there's other measurements you can use as well. Finally, we have tracing. So tracing is a representation of causally related distributed events that document the end-to-end request of flow through a distributed system. So what is tracing? So tracing in a nutshell is special logging that's been added to an application via instrumentation. It's used primarily for monitoring the system. It's a cross-cutting concern, which is a drawback because it impacts every piece of your application. It's very useful in distributed applications where operational concerns make it difficult to resolve errors that occur in our system or discover hotspots. How does it differ from logging? Well, tracing differs from logging that it's often noisy, low-level gathering of information as opposed to high-level information, like exception handling. That's the main difference. So what's the structure of a trace? So a trace is a root outer span with one or more inner spans, or child spans. Each span has its own duration that is captured, and the sum of all is the total duration. Spans are immutable. They contain unique identifiers that allow us to do correlation. A span represents a discrete unit of work through your system. So besides duration, other information may also be captured by spans. A tracing factory or provider creates tracers. A tracer manager manages the active spans within an application. So tracing your application. The first thing we have what's called as a trace factory, provider, or its equivalent. Which create tracers which manage spans. Spans have attributes which are named that are key value pairs of information that we want to store and capture. So what information is captured? So at Couchbase, we capture local host and port name, remote host and port name, interspan durations, application and service-specific data, unique span identifiers, and other identifiers for correlation. We also collect the timeout for that operation. This is all useful for debugging. But you can't have it your way. You can add any information you want, especially if you're adding it to a parent span, which can be passed into the SDK, which becomes your root span. So what is the tool set that's available within the SDK? So what we call, in the SDK, we call monitoring, or we call it response time observability, or RTO. And what that does is it gives you insight into the SDK itself. It's a series of built-in tools for enabling visibility into the SDK. So threshold logging, the orphan response logger, aggregating meter, and raw operation tracing. These are all tools that we use to give us insight into how our application and the SDK is behaving. It's enabled by default, except for tracing. Raw tracing is not enabled by default, and we'll talk about that a little bit later, but it requires you plug in a third-party backend. It's written, these reports, I call them reports, are written to the SDK log. So threshold logging, or logger, is an aggregation of traces which exceed a set threshold value within a specific interval. They're good for detecting slow operations. The threshold value and the interval should be tailored for the environment. It's enabled by default, and if we looked at the parameters that are available, first of all, we have the emit interval, which defaults to 10 seconds. So every 10 seconds, the SDK will generate a report, and if there's any operations that met these thresholds, it will write that operation and some information, additional information, to the log, or to the report, which will go into your logs. We have different durations, or threshold durations, that we use for different services. The defaults are 500 milliseconds for KV, and then 1 second for each of the HTTP services. We also have a default sample size of 10. These are all modifiable and should be to meet your goals. The orphan response logger is a report of the number of operations without responses that are orphaned, that are emitted at a set interval. So what these are example would be a timeout where an operation was sent over the wire, but we never received a response. In this case, it's kind of like a headless body, in a sense. They're good for analyzing timeouts and dead connections. If a large number of operations are orphaned, you may want to look deeper. So, for example, using the orphan response logger and determining, hey, I've got quite a few orphaned operations, we can then say, where is it happening? Is it happening on the application server? Perhaps we're running out of file descriptors, or perhaps it's on the network. Perhaps on the network there's a load balancer that's timing out connections every X number of seconds. Or it's on the cluster itself, the Couchbase cluster itself. This allows you to kind of isolate where the connection is being shut down. And of course, the interval should be tailored for the environment. The aggregating meter is a histogram which shows percentiles for execution time. All our services are instrumented with histograms. These histograms capture the latency of an operation, meaning the request is sent and the request is received, and it's that time span that we capture. We capture the 50%, 90%, 99%, 99.9%, and 100% latency percentiles are collected. Slight differences though, so some of the SDKs may be a little bit different here, but this is most of them use these percentiles. Reports are generated at set intervals. The default is 600 seconds, and the total count is also included. So raw tracing allows us to trace an operation's request and response through the system. It's enabled by default, but requires a third-party OpenTelemetry tracer to export it to a third-party backend. This is done for visualization. Couchbase captures the root span, the encoding span, and the dispatch span. However, you can pass in a parent span, and that parent span can contain application-specific information. So let's look at the tracing and metrics ecosystem. So first, what is OpenTelemetry? OpenTelemetry is a specification and set of tooling for capturing telemetry data. It's vendor agnostic, an open standard, and allows backends to be plugged into it. All Couchbase SDKs are instrumented, meaning any Couchbase SDK can use a third-party backend, or any backend can use the data collected through tracing. So what OpenTelemetry isn't, well, Jaeger, Zipkin, Prometheus, and others, these are third-party backends. So they allow you to visualize your data, your tracing data, and build reports based on that data. That is not what OpenTelemetry is. OpenTelemetry is simply the standard that allows these backends to work properly and to understand that the data coming from your system is readable. So the ecosystem. Let's put everything together here. So you require an instrumented distributed application with OpenTelemetry, a sampler, because you may not want to capture all your data, and an exporter, which is OpenTelemetry as well, for exporting it to a chosen backend. Zipkin, Prometheus, Jaeger, and others. So what are the performance implications of tracing? So 10 Stoffel is an economics acronym that means there's no such thing as a free lunch. And this is true also for tracing, right? So when you enable tracing, things are going to happen to CPU, to memory, to throughput. CPU is probably going to go up, memory is probably going to go up as well, and throughput is likely to go down, along with latency going up. The two are related. The moral here is that everything has a cost. And when you enable tracing, you get a great way of looking into your system and monitoring and giving observability in your system, but at the cost. And the cost is CPU, memory, and throughput. So now we're going to switch over. We're going to do a monitoring example of monitoring using a travel sample example that we have up in GitHub Labs, in Couchbase Labs in GitHub. It's a Python web application. It's based off Flask. Flask is a HTTP microservices framework. And in order to start here, we do need to enable logging on the application. So we're going to enable logging on the application, adjust the threshold interval if needed, and then we're going to run the app and look for a report. So we're going to run the report, rerun the app, and then we're going to go look into the logs. And if we go and look into the logs, we're going to see a threshold report. So what this is telling us is that it's detected some slow queries. So we have two queries here, and they're both about 3/4 of a second, which is kind of slow, right? We should be talking milliseconds here. So we're going to dig deeper in. We're going to try to figure out which ones are slow and why they're slow. And by the way, I know this is a query because the service here is queried. If it was KV, you'd see KV there, and etc. So in order to dig deeper in, we're going to add additional tracing. We're going to add we're going to enable tracing so that we can take our trace data and send it to a third party. So what we're going to do is we're going to install dependencies on the OpenTelemetry SDK and API. We're also going to have a dependency on instrumentation for Flask. So this allows the Flask application, since it's instrumented, to send data to create that root span. And then we're going to create a exporter using an exporter for Zipkin. So within our application, the first thing we see here is this is like I said, a Python application. Is we're going to tell Flask, hey Flask, we want to be instrumented. So this is going to create that parent span. or trace, I should say. Then we're going to create a trace. We're going to have a trace provider creating a tracer, and then we have our exporter. We're going to create that. Finally, a batch span processor, and we're going to add that to our trace provider. Now, these are specific to Python. As other SDKs may be slightly different here. Finally, we're going to create our Couchbase OTel tracer. And we're going to take that tracer and we're going to pass it into the constructor of the cluster object. So once we've done that, now we can, when we run the application, all that trace data that's collected, it's going to be sent to our third-party backend. In this case, it's going to be Zipkin. So we're going to run it, and then we're going to go into Zipkin, and Zipkin's got this nice web UI, and we're going to kind of analyze really quick. And what we see here is that, you know, going from the bottom, we see some pretty fast queries, and then we see these slow requests. It looks like for this particular path, you know, we're talking about looks like 3/4 of a second, right? Which correlates with what we saw in our log, in our RTO log. So if we click the show button, we can dig in. We can dig in and look at the entire trace. So this is the trace that it was created partially by Flask and the OpenTelemetry instrumentation. In it, you see the web request at the top, and then you see there was 2 queries for that web request. The first one looks pretty fast, right? We're 4-5 milliseconds, roughly. Then the second one, you see the slower queries. We're looking at about 3/4 of a second there. That's pretty slow. So let's dig into the annotations now. So the annotations itself are what are called attributes, and these are the additional data that we've added to our spans. And if we look at it, it looks like maybe it's the database statement. So maybe it's the query itself. Just looking at it, maybe we're missing an index or something. That might make sense because the query itself is pretty straightforward. So let's hop over to Couchbase and look at the indexes. And when we do, what we're going to see is that there's only a primary index created for this route data. That makes me think that maybe we need to add additional indexes. So we're going to add 3 more indexes. One for source destination, one for schedule, and one for source airport. We'll see if this speeds things up. So now we're going to rerun our application and then visualize and see what we see and visualize it in Zipkin. And when we do, we see our older queries from 26 minutes ago are pretty slow, but all the most recent queries are fast, especially at that path. So what it tells me is that, hey, look, we figured out what our problem was. And if we look at an individual trace, we see, sure enough, that's a lot faster now. Now we're about 12 seconds for, not 12 seconds, 12 milliseconds for a query, much faster. Thank you. If you wish to contact me, here's our contact information. I'm Jeff Morris and a co-presenter, Dave Kelly, as well. Thank you.